So let's start with problems 1 through 8. Are there any questions on 1 through 8 or how to look at these here, or one that we want to look at in particular? On problems 1 through 8. I handed it out on Thursday. So there is a digital version in Google Classroom. So if you just want to follow along on a piece of paper. There you go. So you can follow along with this here. So questions 1 through 8. Is there one of those in particular that y'all want to look at or see work? Okay, so we want to write it in interval notation, so we're using our parentheses and brackets. Now the smallest number that this can be is the biggest. The negative 256 would have a, and the 100 would have a, because it is equal. We use parentheses when it's not equal, and we use brackets when it is. Well, let's look at number 3. So number 3, x is greater than or equal to negative 174. What is the smallest number in this? What's the biggest number? 174 would have a, and infinity would have a. Because infinity, we can never reach it. It is never contained. So parenthesis will always be used with negative infinity and infinity, because infinity is a more conceptual than an actual number. Any other questions on 1 through 8? Are we good with problems 1 through 8? Yes? Nine through 14. 9 through 14. Is there a problem in 9 through 14 that you all want to specifically look at? 10. Number 10 is the set of all integers. X is greater than or equal to 200. So we're going to start off with our curly bracket x. Now, most of the time we would do x bar, which is really saying the set of all real numbers x such that fill in the blank. But here, we don't have the set of all real numbers. We have the set of all what? Integers. So we're going to say x is an element of the integers such that what? X is greater than or equal to 200. Now, the big thing with set builder notation is we cannot have any interval notation inside of the set builder. So with like problem number 9, we have to change parentheses negative 24 comma 87 bracket into interval notation. So this interval notation, sorry, inequality notation, because we need our greater than, less than symbols. Any other questions on 9 through 14? Any other one of these here that we want to look at or go over? 14. So here we have parentheses negative infinity comma negative 4 bracket, or parentheses 4 comma infinity. Well, for us to be able to use set builder notation, we have to take this out of interval notation and write it in inequality. So for the first part here, how would I rewrite this? Well, we would have x is what? Less than or equal to negative 4. Or our other statement would be x is greater than 4. Would be our two statements. Because our negative infinity comma 4 bracket is saying that all the numbers less than negative 4, and it is equal to it. 4 comma infinity in parentheses on both sides is telling me that I have everything greater than 4. So we have this statement. Now we can go on and start the set builder notation. Now, because it is an interval, we're talking about the set of all real numbers, such that what? X is less than or equal to negative 4, or and and that is it. Any other questions on this here? Are we good with this here? Any other questions on 9 through 14? Any other one of those that y'all want to look at? 14?
I have a question.
Yes.
But it's not on Spartan before.
Okay. Number 4.
So, that means it's finished.
No,
Or is that a time?
that's the variable x.
Yeah, so that means it's finished.
So how would we read this? 6 is less than or equal to x is less than or equal to 247. So we're saying that it's considered to be all the numbers between 6 and 247. So it'd be bracket because of the equal sign, comma, 274, bracket. We're using x to define any number between those two. Any questions on 1 through 14? Any questions on 1 through 14? Okay. There are no other questions on 1 through 14. Let's look at 15 through 18. 15 through 18. Are there any questions on one of those or one of those that y'all want to see worked? 15. So if we're going to work this out, I need to pick a variable to eliminate first. What variable do we want to eliminate out first? Why would we pick y? It's all the same, right? Because it's 5y, 5y, and 5y. They're all the same. I don't have to change any of the equations, no matter which one I pick, for the y values to have the same number in front. Why don't I change it up? Let's use the top equation. I used the bottom one during the first 2 hours. So we can just go on and write the other 2 equations down. 5y plus 4z is equal to 19. X plus 5y minus z is equal to negative 20. Now we can just go on and write the eliminator equation down because the values in front of y are already the same. So there's nothing that we need to do to get them to be the same for the value in front of y. Now once we get this written down, let's look at the left one first. Would we add these 2 equations together or subtract them to get the y's to cancel? So we have negative 5y, negative 5y, yes? Negative 5y plus negative 5y would give us what? Negative 10. Because a negative and a negative added together make a bigger negative. So we would need to subtract these. Because if we subtract negative 5 minus negative 5, a negative and negative make a positive, so we'd have negative 5 plus 5. And if the negative negatives and all that kind of get a little jumbled in your head, go on and try it in a calculator. So especially when doing these here, go on and plug them in. Don't just cancel them out because that's what we want. We want to make sure it does work out. That way, especially if we did subtract on the test, well, or add on the test, negative 5 plus negative 5 in the calculator, we hit it, it tells us negative 10. Okay, we need to subtract instead of add because we need those to cancel. So when we subtract 4x minus negative x, well, negative and negative make a positive, so this would be 5x. As we see here, negative 5 plus 5 is 0. Negative 4, or 4 minus negative 5, well, the negative and negative make a positive. 4 plus 5 is plus 9. Z is equal to 17. 19 minus 2. Okay, well that takes care of that one equation because I had two equations with three variables. Now I have one equation with two. Let's look at the other side. Again, we want the values of y to cancel out completely. So would we add or subtract? We would add because 5 plus negative 5 or 5 minus 5 is 0. That's exactly what we want. So here we would add. X plus negative x is 0. 1 plus negative 1 or 1 minus 1 is 0. 5 plus negative 5 or 5 minus 5 is 0. Negative z plus negative 5z is negative 6z is equal to negative 20 plus 2 is negative 18. What would we do next? Divide by negative 6. If I have one variable, might as well go on and solve for it. It'll make it easier to work. Z is equal to 3. Z is equal to 3. So this one here worked out nicely that we ended up getting a variable by itself. That is nice. Well, the other equation we got was in terms of x and z. We know what z is already. Yes, it is 3. So I come over here and say 5x plus 9 times 3 is equal to 17. 9 times 3 is? Then what? Subtract 27. And we get 5x is equal to negative 10. Last but not least, we divide both sides by. Any questions on how we got x and z? Now, I just picked one of the equations. Negative x minus 5y minus 5z equals 2. It doesn't matter which one we pick. I just picked one. You could pick any of them. They'll give you the same thing. Now we just need to get y. And the way we get y is by picking one of the equations we already have, plugging in the two variables that we found to find the last. Well, negative 2 is just 2. Minus 5y, negative 5 times 3 is minus 15 equals 2. Negative 5y. 2 minus 15 is negative 13. At this point here we can add 13 to both sides, which tells us negative 5y is equal to 15. Last but not least, we would divide both sides by negative 5, and we get y is equal to negative 3. So the answer was negative 2, negative 3, and 3. And that's it. How else could we have solved this? We could go over another way to solve these. Put it in the calculator. So what were the instructions for these here, these three variable systems? Solve each system by any method, yes? Is plugging it into the calculator a method to solve these? Yeah. The only time you'd have to do it by hand if it specifically asks you to solve it by hand. If it doesn't, if it says any method, the calculator is a perfectly acceptable answer or acceptable way to solve these. Any other questions on 13 through, or 15 through 18? Are we good with 15 through 18? Yes? Okay. Questions on 19 through 24. Which one of those do we want to look at? 22? I do not know off the top of my head. So we look at number 22. When we write an augmented matrix, we want all the variables on one side of the equal sign and the numbers or the constant terms on the other. So we look at this here, x, y, z, x, y, z, x, y, z. All the variables are on one side of the equal sign. All the constant terms are on the other. And the other part was that the variables are all ordered in alphabetical order. So we have x first, y, and then z. And all three of these here are set up as x, y, z. So we're good. Now we just need to take the coefficients, the numbers in front of the variables. So I'll start off with the top equation. So I'd have 6, -2, 3, and then 1. The next one would be 9, 1, 9, 9. And then we'd have 1, -21, 1 and 4. And that right there would be the augmented matrix. Now the only other part of this question that we haven't done yet is to state the dimensions. And the dimensions for this would be 3 by 4. Because we always go down and then over. 1, 2, 3 going down, and 1, 2, 3, 4 going over. And that'd be it. That's all we have to do for these here. Any other questions on these here, 19 through 24? Is there another one of these that we want to look at? I'll go on and look at 21. It is already set up x, y, constant term. So this would be what? 11, 4, 2, 6, -3, and 7. This here would be a2 by 3. Now, why won't we put any zeros in for z? Well, neither one of them has z. That's right. Because a variable has to be included in the augmented matrix if it shows up how many times? At least once. If it shows up once in any of the three or any of the two equations, it has to be included for all of them. It has to be represented in the augmented matrix if it shows up at least once. Now for most of what we'll do is we'll have either, if it's two equations, we'll have two variables. If it's three, it'll have three for the most part. But we won't cover any cases where we'll have two equations with three variables. It can happen, but most likely it won't show up. Questions on this here? If we feel comfortable with those there, let's move on to 25 through 31. Is there one of these that y'all want to look at? $27? Let's look at number 27. Now, again, I would go back to our y equals equations because the y equals equations are going to make these a lot easier to work with. So I would definitely have these on the review sheet somewhere. Might be on the back. It might be the biggest place of white piece of paper for y'all to write those down. But those will be very helpful. I have posted those to Google Classroom if you want to write those down later. So when we look at this here, we're told that the function f of x is equal to 6x minus 1. We want to translate it up 3 and reflect it across the y-axis. Now we're always going to start off with whatever the first move is. So I'm mainly just going to worry about the translation of up 3 first. Now this here is a vertical translation. So we're looking at the form y equals f of x plus k. So we're talking about f of x plus our value of k. And what is the value of k? 3. And it's going up, so it would be positive. It would be a positive 3. So we can just say plus 3. So we still have f of x. We didn't do anything to it. So I can just replace f of x with its function, which would be 6x minus 1 plus 3. Now we can go on and just drop the parentheses and have 6x minus 1 plus 3. And well, negative 1 plus 3 is plus 2. So we've successfully moved the function up 3. So we did the first part. Yes? Now the next part is what? A reflection across the y-axis. Now I'll call this g of x. Now for a reflection across the y-axis, we're talking about f of negative x. That's our reflection across the y-axis. Y equals f of negative x. So for us here, it'd be g of x is equal to h of negative x. Because the g of x, h of x, that really doesn't matter. It's just a way for us to define the function. Because we're not going to use f of x at this point because we're not talking about the original function. We're talking about the one that was moved up 3. That's the one we're reflecting. Because we're reflecting this one right here. So we'll call it h of x. Well, I have h of x here, yes? What do I have here? H of negative x. I've replaced x with negative x. That means everywhere in the function I need to replace x with negative x. So we'd have 6 parentheses negative x plus 2. Well, 6 times negative x is negative 6x plus 2. That's it. Now again, this might seem like a lot, and there's a lot going on with these transformation here. But when we do it one step at a time, it takes the difficulty level way down. Yes? Do we agree with that there? So having these down, all the y equals, is I think going to be very helpful. Because when we start looking at it, not trying to remember exactly every little thing, translation up 3. Okay, well that's vertical. That's my f of x plus k. Plug in k, then plug in the function as needed, simplify, move on to the next one. And we do that one at a time. Any other questions on these transformations? Or another one that you want to look at? Are we good to move on to 26? Everybody's translate 4 right in up 3. So the first thing we want to do is move it 4 to the right. So I'll call it h of x is equal to f of what? Which one would we use? Left and right is horizontal, isn't it? So it would be our y equals f of x minus h. So inside here I'd have x minus h. So how far are we moving it? 3 units to the, or 4 units to the right, yes? Right is positive or negative? Right is positive, so h's value is positive 4, yes? So here I would plug in a positive 4, but how it looks is x minus 4. It'll look like x minus 4. Now, if it had been left 4, we would have plugged in a negative 4, and a negative would make a positive. So it still is going along with that opposite of what we think. Okay, well, that part's set up. Well, again, like on the last one, I don't have h of x here. I don't have f of x anymore. I have f of x minus 4. I've replaced x with x minus 4, which means everywhere in the function, I need to replace x with x minus 4. So we'll have 2 times x minus 4 minus 1. What do we need to do next? We need to distribute the 2. 2 times x is 2x. 2 times negative 4 is negative 8 minus 1. And negative 8 minus 1 is negative 9. Okay, we did the 4 to the right. We have that finished. Now the only other thing is to do what? Move it up 3. So our basic version of vertical translation was our f of x plus k. Well, here it would be g of x is equal to our h of x plus, what's the value of k? 3, and it's positive because we're moving up, yes? So it'd just be plus 3. So what is h of x? The absolute value of 2x minus 9. And then we have our plus 3. Face forward, face forward. Thank you. So we went on and just replaced h of x with its function, the absolute value of 2x minus 9, because it's the one that we already did the right for too. Now, because there's nothing outside the parentheses, we can go on and drop them. And we just get this here. And that's it. That's all we'd have to do for this here. Any other questions on any of these transformations? Okay. If we have time, we'll come back. I think there's probably a good chance that we will. 30 and 31. So these two here do line up with your 32 and 33. This was an old from the sheet before I added the 2 for horizontal stretch and shrink. So the numbers are a little off from the one I have up here. Are there questions on these two problems, on how to do either one of these? So if the dimensions are the exact same, we add or subtract like elements. So what would we be adding and subtracting here? So 2 would be what? 2 minus 1 plus 3, because these are all the same element, and we're just using the operations in the middle. Now the next one we can have is 7 minus 4 plus 8. And here we would have 9 minus 16 plus 7, and then we would have 8 minus 16 plus 2. Now, we normally would do 2 of them, and then once we simplify that, we would do the third one, but we could do all 3. We just need to be careful with scalars. If there's a scalar multiplication in front, we do have to take that into account. Could I plug this in the calculator? Because what would I do? I would define this as A, B, and do A minus B plus C. Even if it had scalars, I could say 2A minus 3B plus 7C, and it would do the exact same thing. So here 2 minus 1 is 1 plus 3 is 7 minus 4 is 3 plus 8 is 9 minus 16 is negative 7 plus 7 is 8 minus 16. 8 minus not 16, it should be 27 is negative 19 plus 2 is negative 17. And that's it there. Any other questions on 33? We good with problem number 33? Questions on 32 or 33 are these two here. So, yeah, the numbers are off. Yeah, because that'll just go right there. What was the answer to number 33? Not possible, because what do we have? We have a 3 by 3 and a 3 by. Can we add those? If we add or subtract, they have to have what? The same dimensions. If they have the same dimensions, then we can add or subtract. If they do not, we cannot. Huh? Okay. Well, what do we do first? We multiply by 2. 2 times 3 is 6. 2 times 1 is 2 times 4 is. Here I'll multiply by negative 4. Negative 4 times 8 is negative. Negative 4 times 6 is. Negative 4 times 7 is negative. And then we have plus 3, 3. Add them together. 6, we have 6 minus 32 plus 3. 2 minus 24 plus 3. 8 minus 28 plus 3. 6 minus 32 is negative 26, plus 3 is negative 23. 2 minus 24 is negative 22, plus 3 is negative 18. And 8 minus 28 is negative 20, plus 3 would be negative 17. And again, we could have put this in a calculator and defined the three matrices as A, B, and C, and said 2A minus 4B plus C, and gotten the answer. Any other questions on this here? Well, these two here would be the exact same thing. And really for this one here, I would highly suggest just putting it down. Questions on 38, 39, or 40. 38, 39, or 40. Finding the equation and describing the graph, or describing the slope. They're one of those that y'all would want to look at. Well, I'll just go on and pick 39. Did they give us the y-intercept? Did they give us the y-intercept for this here? No. They didn't really give us the slope either technically, but we'll be able to find it. Because y2 minus y1 over x2 minus x1. Well, what are our two y values? Minus 40, because again, these points are x comma y, x comma y. So 90 and 40 are our two y values. The corresponding x values would be 40 minus 15. Well, 90 minus 40 is 50. And 40 minus 15 is 25. And 50 divided by 25 is 2. Now, since they didn't give us the y-intercept, we're going to have to use point-slope form because we have a point and we have a slope. So I went on and plugged the slope in because we know the slope is 2. What point do we want to use? So what y value do we want to use? So we can take 90 and 40. It doesn't matter which one we use, we'll get the same thing. Now, once we plug both in, we need to get y by itself. We have y minus 90 equals 2 times x is 2x. 2 times negative 40 would be negative 80. At this point here, we would add 90 to both sides. And we would get y is equal to 2x. And negative 80 plus 90 would be plus 10. And even if we did use 15 comma 40, we would get the exact same answer. We would get the same answer either way that we did this. Any questions on how we found the equation of the slope, or equation of the line? Now it asks us for us to define the slope or interpret the slope. So we can say for every minute of practice, what happens? 2 pitches are thrown. Because our slope is 2 or 2 over 1. Our x is time spent practicing in minutes. And the y-axis is the number of pitches. So for every 2 minutes, or for every 2 pitches, 1 minute has passed. Or for every minute that's passed, 2 pitches have been thrown. Any other questions on 38, 39, or 40? Are there any other questions or anything else you all want to look at on the review sheet that we didn't get to? Okay. So did they give us the y-intercept? It is. Does this go up or down at all? So the slope is, so y equals 0x plus, so y is equal to, would be the equation. Yep, it's a constant function because it does not increase or decrease. And if we really want to describe the slope, it's staying at a constant speed of 65 miles an hour. Any other questions on this here? So I would have those written down at somewhere on your page.